Life's got problems, let's find solutions. This video is on the importance of naming, and I've got a couple of goals that I have with this. What I want to do is show you an AP level problem that is pretty basic, but requires the skills that you learned in your previous chemistry class, or hopefully learned in your previous chemistry class, so it'll give you some good review. I also want to show you the way that we're going to add up molar mass in our class, so some specifics on that. I'm going to show you also how the grading would be given to you, like how you could earn points in doing that type of a problem in my class. And then all of this is, of course, with a naming twist to show you just really how important it's going to be to learn your naming in my course. Now, I'll admit also, the AP exam, AP Chemistry and College Board, they've admitted that they're not going to do as much naming these days. So some might ask, well, why make it still part of your course? Why make it as important as it is in earning the points in your class? And the reason I'm doing this too is because even though that's what College Board says, I have talked to multiple chemistry professors from more than one university, and they all admit that they still do naming, and they expect that if you make it to your second year of chemistry, that you have those naming skills. So what I would hate for you to do is get all the way through my course and never have to really touch naming much, and then you get to your second year of chemistry, college chemistry, and you're like the one person in the class who doesn't know what potassium permanganate's formula looks like, or what butanol's formula would be. So naming is important. Whether it's going to be huge on the AP exam or not, it's important that you get those skills in this class, so that way if you do get that 3, 4, or 5, or whatever score you're going to get to go on and pass out of the first entry-level chemistry class, that you have that skill in place and you know how to do those formulas. So let's go ahead and get started. Here's the start of a problem that is a good example of something we might encounter in the first portion of our term in AP Chemistry. It's very similar to something you might have seen in your previous chemistry class, except we're not giving you any of the formulas. We're just giving you the name of chemicals. When zinc carbonate is heated, carbon dioxide gas is evolved and zinc oxide remains. Evolved, by the way, is just another way of saying the gas is produced. You gotta read plenty of these questions, just get used to the wording and what words mean. A student begins with 15.0 grams, so I'm already seeing 3 sig figs there, of zinc carbonate and heats it until gas is no longer produced. So in other words, they're running the reaction until it's at completion. Part A. Write the balanced chemical equation for the process. Now, in my class, and it might be different if you're in some other class, if you just stumbled upon this video and you aren't taking my course, maybe your teacher or instructor grades differently. But for my class, this might be something like a 5-point type of question. 2 points I'd give you for correct reactants. In this case, there's only going to be one reactant, but normally that might be how I'll grade. 2 points all or nothing if you've got the correct formulas for the correct reactants. 2 points for the correct product or products. Should have had a little S there. Let me add that. Thank you. And I also have 1 point balanced conditional. Conditional means you got to get the other 4 points before you have access to this 1 point for balancing. In other words, if you totally botch it and you just put ZnCO, and then you draw an arrow and you put ZnO and then a C, plus C. If you have nothing that even comes close to looking like these correct reactants or products, but you put a bunch of 1s for the coefficient, yeah, it's balanced, but it's very wrong. So I'm only going to give you access to that balanced point if you've got the rest of the problem already correct. There's 5 points right there. The question continues and goes on. Calculate the molar mass of zinc carbonate. That'd be a 5-point type of question in my class. For just about any calculation, I'm usually going to give you 5 points. 2 points of that 5 comes from having the correct value, the correct number. There's 2 points number sign. That's not a hashtag, that's a number sign. Come on now. So 5 points, 2 of them comes from having the correct value. And then you got some other partial credit points here. I'm going to give you 1 point for showing me some logical work. You can't just scribble anything down, but if you try to at least do some logical things with the numbers, I'm going to give you a point there. It's probably the easiest point you can earn of these 5. 1 point if your value, whether it's wrong or right, is rounded to the correct number of significant figures. So you can get the value wrong, but still get that sig fig point. And then 1 point for the correct units. I hope that you know the units for molar mass is grams per mole. So little g/mol. Part C. If the carbon dioxide gas is collected over water, dried, and brought to STP conditions, what theoretical volume is expected? That's another 5 points. Same pattern as the previous one. 2 points for the number, 1 point unit, 1 point sig figs, and 1 point for your work being shown. And then part D, if at the end of the experiment 2.10 liters are collected, what is the percent yield? This would be a percent yield by volume. Now, you can see that this is then a 20-point question. And a lot of these points really hinge upon, do you know the formula for zinc carbonate? Never really asks you, other than writing the balanced chemical equation, for the formula, but still, so many of these points will be lost if we don't know what that formula is. So let's start at the beginning, write a balanced chemical equation for this process. Zinc carbonate is heated, carbon dioxide gas is evolved, and zinc oxide remains. In order for you to get the correct formulas, you have to know your ions. You've got to know that zinc not only is Zn, but you have to know what charge it has. Zinc has a +2 charge. That's the most common oxidation state. Not saying other ones aren't possible, but you won't really encounter any other than +2 in AP chemistry. Carbonate. You have to know that formula as well. Carbonate is CO3 with a -2 overall charge. If you have either of those things wrong, you're going to be in a tough spot trying to get this correct balanced chemical equation. When these two come together, since zinc is +2 and carbonate's -2, you only need one of each, one cation and one anion, in order to balance the formula. So we get ZnCO3. And of course we don't show charges once they've been balanced. They are still present in the compound. It's all charged ions holding it together, but in the formula we don't show them anymore because the charges have been balanced. A whole lot of chemistry is all about balancing. It's heated and then we produce, so we draw our arrow sign, here's our products. Carbon dioxide gas. I'm guessing that you probably don't struggle with knowing carbon dioxide's formula by now. And we also get zinc oxide. Here's another place where we need to know our charges. Oxide is a -2 charge. That one's pretty easy to predict just from its location on the periodic table. But that means we're only going to need one zinc to go with one oxide, so we have ZnO. And then, of course, to balance it, if you don't put any numbers there, then it is assumed that you put a 1. But I like to just write them in just so we can verify, yes, we did know that it was all 1s, and we have a completely balanced chemical equation. There's your 5 points. 2 points for getting this formula correct, 2 points for getting your product formulas correct, and then an additional 1 point for having it balanced. If you were to do this in my class, I would want you to throw in the 1s to verify for me that, yes, Mr. Lund, I saw that it was already balanced, so I threw in those 1s. I didn't just get the formulas and then give up on the balancing. So that would get you your 5 points. Now, what if I forgot what zinc's charge was? Let's just deal with that scenario. What if I thought that zinc was +1? If I thought zinc was +1, I would be putting 2 zincs with 1 carbonate. That's, again, assuming I got the carbonate correct, but just not knowing that zinc was +2, if I thought it was +1, I'd write this for my zinc carbonate formula. And then I'd produce my carbon dioxide, and I would produce Zn2O if I thought that zinc had a +1 charge. Then when I go to balance it, yeah, I'd still have a bunch of 1s. These would all still be coefficients of 1. Everything would be balanced, but my formulas would be wrong. How many points would you get for this? Are your reactants correctly made? Nope. Products? Well, no. Your zinc oxide's wrong. Yeah, it's balanced, but you didn't get the formulas correct. This would be 0 points. So already you'd lose your 5 points for this right there. What if I thought that zinc was a +3 charge? Well, then I'd be having 2 zincs go with 3 carbonates. I'd produce my carbon dioxide, and with a +3 charge, I'd have 2 zincs with 3 oxides for zinc oxide. And then when I go to balance this one, well, I'd have a 1 here, a 3 here, and a 1 there. Yes, it'd be balanced, but again, your formulas would be wrong. These both would score you 0 points. So already 5 of your 20 points for this question comes from, did I know what my ions were? And we just dealt with, do I know what zinc's charge is? What about carbonate? You got to remember that formula as well. If you thought carbonate was CO2 or just CO or something else, or you didn't know what its charge was, you could also not get these points. So here is our correct balanced chemical equation. Now I will admit there is maybe a rarity where maybe I think mistakenly zinc is +1 and carbonate is -1, and if the other formula is the CO3 is correct, then yes, you could still accidentally get to this and still get the 5 points, but that's pretty tough, pretty rare to have happen. So part B, calculate the molar mass of zinc carbonate. Now, we have to talk about how things work in my AP class. Do you need to use all of those mass numbers, all of the average atomic mass decimal place numbers in adding up your molar masses? No, you do not. What I hold you to, and what I have everybody in the class do, is round to the tenths place. Whenever you take one of those average atomic mass values off of the periodic table, it must be rounded correctly to the tenths place. We don't want to have to write all of those numbers. And I have asked multiple times at our College Board conferences, just to make sure that they're still giving me the same answer, how far do you need to have those values rounded to? And they are okay with it being rounded correctly to the tenths place. So in my class, here's the periodic table that we are given. We should be rounding zinc to 65.4. For zinc carbonate, so you've got 65.4 for zinc. And when you're showing me your work, you don't have to show me the units in your work. It helps for dimensional analysis, as shown to you in previous videos, but you don't always have to do it for every single step. You do have to have the units in your correct answer, though. For carbon, we should be rounding that to 12.0. Get in the habit of showing those point zeros, because if you just call it 12 and you go back and check for sig figs, then you might accidentally round to the wrong number of sig figs. And then we've got 3 times for oxygen, 15.999, that should be 16.0. We should be getting 125.4, and then our correct units should be grams per mole for a molar mass. Notice also the way that my class works, since you have to round every molar mass to the tenths place when you take it off of the periodic table, then that means we're going to be adding everything into something where your molar mass will be just to the tenths place. Even if we have 3 times our 16, that 3 is infinite in sig figs. So when we do, this is kind of technically a switching gears type of problem, but your 3 times your 16.0 gets you 48, so that should really be 48.0. When we're adding these all up together, you'll still get your molar mass to the tenths place. Also, instead of multiplying this by 3, I could have just added this out and said, 65.4 plus 12.0 plus 16.0 plus 16.0 plus 16.0. And so everything then would just be significance to the tenths place. And so that would still get me my correct tenths place value. If I had gotten zinc carbonate's formula incorrectly, though, as we showed you in these other two, I would have my molar mass incorrect too, wouldn't I? In which case, yep, I might get 1 point for the sig figs, 1 point for the unit, and 1 point for showing work. Even though it was wrong work, it was still a logical idea. That would only be 3 out of your 5 points if you didn't know your naming.